Welcome to The Explainer. Today, we're going to break down one of the most incredible feats of modern tech, how a machine actually learns to see. It really feels like a bit of everyday magic, doesn't it? You hold up your phone, it just knows it's you and unlocks. But what's actually happening in that split second? How does a chunk of metal and glass recognize something as unique as your face? Well, here's the thing. At its core, a computer doesn't see a face at all. It just sees a grid of pixels. Every tiny square is just a number for its color, for its brightness. So the real challenge, the whole puzzle, is how do you get from this giant grid of numbers to one simple idea? Hey, that's you. To solve this incredible puzzle, scientists looked for inspiration in, the most powerful computer we have, the human brain. And what they found is that this amazing ability is built up from a surprisingly simple starting point. This right here is the basic building block, the artificial neuron. Just think of it like a tiny decision maker. It gets a bunch of signals from other neurons, it adds them all up, and if that total signal is strong enough, it fires and sends its own signal forward. It's basically a simple on or off switch. But here's the key, and this is the really clever part. Not all those connections are equal. Each one has what's called a weight, which is kind of like a volume knob. A high weight means that signal is super important. A low weight means, not so much. And the entire learning process is really just about the network figuring out how to tune these millions of tiny knobs perfectly. So a single neuron, it can't do much on its own. The real power, the magic, happens when you connect millions of them together in layers. And the best way to picture this whole thing is like a highly specialized assembly line, but an assembly line for seeing. So an image, that grid of pixels we talked about, it goes in one end, that's the input layer. Then it passes through all these different hidden layers, and that's where all the heavy lifting, all the processing happens. And then finally, out the other end comes a really simple answer from the output layer, like cat, dog, or, your face. The first group of neurons on this assembly line, their job is dead simple. They are the edge detectors. All they do is scan the image for the most basic stuff. Horizontal lines, vertical lines, maybe some simple curves. They don't see a face, not even close. They just see a bunch of primitive shapes. Then, the output from that first layer gets passed down the line to the next. This next group of neurons takes those simple lines and edges and starts putting them together. So, for instance, a few curved lines might form a circle. 4 straight lines might become a square. We're building up from simple lines into basic shapes. And this layering is what makes the whole system so incredibly powerful. Deeper in the network, you have neurons that get these collections of simple shapes and learn to recognize much more complex patterns. A couple of circles and lines can become an eye. Another combination of curves and lines might form a nose. The network is literally assembling the image, piece by piece, getting more complex with every step. So how does this assembly line actually go from just seeing shapes to making a real decision? Let's use a simple example to see how the network truly learns to recognize something. It all comes down to training. During this phase, the network is shown thousands, maybe millions, of labeled pictures. It learns that pictures labeled starfish very often have features like a ringed texture and a star-shaped outline. Meanwhile, sea urchins tend to have a striped texture and an oval shape. Every time it sees one, it adjusts those internal knobs, the weights, to strengthen those connections. So when a brand new, unlabeled image comes in, the network's assembly line gets to work. The early layers find edges. The next layers find textures and outlines. And if the star outline neurons and the ringed texture neurons are all firing like crazy, they send a really powerful signal to the final output neuron, which then confidently declares, yep, this is a starfish. And this right here is the most important takeaway. No one ever programmed a rule that says a starfish is a 5-pointed shape with a ringed texture. The network figured that out completely on its own. It learns the patterns directly from the data by adjusting those millions of tiny knobs until it consistently gets the right answer. So this whole process of learning from pixels, it's not just for recognizing starfish. It is the engine behind some of the most transformative technologies that we use every single day. I mean, that's how your phone sees your face. It's how a self-driving car identifies pedestrians and stop signs. It's how radiologists get help spotting tumors in medical scans. And it's how your photo app can somehow find and tag every single picture of your dog. Each one is just a neural network, trained for a very specific visual job. And these networks have become unbelievably good at what they do. I mean, in a lot of standard image recognition tests, they now perform with over 99% accuracy. They're often outperforming the very humans who created them. And that's a level of performance that was pretty much science fiction just a couple of decades ago.
So we've built a machine that can learn to see. The question that leaves us with is, as this technology keeps getting better and better, what will it learn to understand next?